Hey everyone, welcome back. In this lesson we are going to be reviewing the order of operations, otherwise known as BEDMAS. You may have heard this described using a different acronym, and we're going to go through the different variations that I've come across. But basically in this lesson we're just going to review this concept to use as a foundation for work that we do later in the course. And the reason for that is that if you don't have this foundational understanding right now, then the rest of the class might get kind of difficult, like the rest of the classes in the future might get a little bit difficult because this really is quite an important concept for some of the things that we're going to end up doing a little bit later on. So the order of operations basically tells you the steps to follow when you are solving a math problem. So this could be a problem that's working entirely with numbers, like the one shown on the screen. It could be one where you're working with some numbers and some variables, some letters that we'll see when we get to algebra. It could even be done entirely with letters and symbols and things like that that aren't numbers. So you can do this in basic math classes where it's just numbers, like the example on the screen, or it can be in something like university class, you're trying to derive some fancy equation, starting with one equation and trying to turn it into a different form. You'll still use the order of operations to get there. So the idea here is that if you're just looking at the equation that we see on the screen, we need to know what we're supposed to do first. What does it mean if you have an operation like the addition that's there in brackets? What does it mean if you've got an exponent, which we don't see in this problem, but what does it mean if if you see multiplication and addition and division, what order should we do them in? Do we go left to right? Do we do a particular operation first? What's the deal with the brackets? All of that stuff. So what we're going to start with is we're going to tackle an example similar to this one after I lay out what the order of operations actually is. So the way we remember the order of operations is with an acronym. The one I learned when I was growing up was BEDMAS, and that's this one right here, and the one that's shown down at the bottom there. But I'm also going to explain the meanings of these other variants, which are PEMDAS and BODMAS. So the way it works is basically we'll start with BEDMAS, and then the other two are really similar, so it'll be a much quicker explanation for those. But basically BEDMAS stands for brackets, exponents, division, multiplication, addition, subtraction. So that's the way it functions. What it means is that when you're looking at a problem like the one that we had on the previous slide, you will always start by solving whatever's inside brackets. So if you've got a whole bunch of stuff in your expression, if you've got a whole bunch of different terms, some are being added, some are being multiplied, some have exponents, some have brackets, you'll always start with whatever's inside of the brackets. You forget about everything else and you will solve what's inside the brackets. If you've got two sets of brackets, so you've got like a couple terms and then something with brackets and then a couple terms and then something else with brackets, so you've got, something something plus something that's inside brackets, and then you've got, a whole bunch of other stuff, and then another set of brackets, could be added, could be multiplied, whatever, then you're going to start off by dealing with whatever is inside of this set of brackets, and then deal with whatever is going on in this set of brackets, and ignore everything else. So if you see the same operation or the same thing from this BEDMAS list over here, if you see it coming up more than once, then just go from left to right. So like start with the brackets on the left, so this one, and then once you're done with that, go to the brackets on the right, and then tackle, everything else. So whatever's out there and over here. So The idea is you'll always start off with solving what's inside the brackets, and then once that's done, so if we're doing a mathematical problem, only numbers, no variables, no other symbols, nothing like that, then you'll be done working with the brackets once you've got a single number inside here. So it could be like a 6 here when you're done solving this one, and a 2 here when you're done solving that one. So once you've got it down to a single number inside of all of the brackets, you can move on to the next step, which is exponents. So exponents are when you have a term that's got a little superscript, a little number out here, like that. And basically it's telling you that if you've got a little 2 up here, that's telling you that you need to multiply this thing by itself 2 times. So if you've got 6 squared, or 6 to the exponent 2, that's the same thing as 6 times 6. If it was 6 cubed, or 6 to the exponent 3, then it would be 6 times 6 times 6. There'd be a third 6 in there. So you'll deal with, once you're done dealing with the brackets, then you'll move on to dealing with any terms that have exponents. So you'll turn the 6 squared that we've written up here, you'll turn it into 6 times 6 and just calculate that in one step. You don't need to turn it into multiplication and then sit there. You can actually solve it. So 6 squared is equal to 6 times 6, which is equal to 36. So then you could replace these brackets, this entire thing with brackets, and the exponent with just the number 36. Once you're done with exponents, then we move on to division and multiplication. And so with that, these two are, why can't I draw? There it is. Okay. These two are the same operation, just in opposite directions, right? If you wanted to undo multiplication, you would divide, and if you wanted to undo division, you would multiply. It's basically the same operation, they just work in opposite directions. So it's not that division always has to happen before multiplication, or multiplication always has to happen before division. These two happen in whatever order they appear, going from left to right. So like if you have 4 divided by 2 times 8, so if you've got something like this, then just go left to right. So first do the division, so first do 4 divided by 2, and then when you have your answer to that part, take that answer and multiply it by 8. On the flip side, if you had the multiplication showing up first, so if you had 4 times 2 divided by 8, like so, then start with the multiplication because it shows up first when you start at the left. When you have an answer to that, then go ahead and do this division and divide by 8. So once you're done with the division and multiplication, you should only be left with things being added together or subtracted together, because that's all that we have left in our order of operations over here. And just like how division and multiplication are opposite operations and they just you just do them in order from left to right, addition and subtraction work the same way, because addition and subtraction are opposites of each other. So you just do the addition and subtraction in order from left to right. So the same idea as what was going on over here with the division and multiplication. So that's basically an explanation of BEDMAS. I know there was a lot of my handwriting with my keyboard and stuff on the previous slide, which isn't the neatest way to go about this. I just wanted to explain the steps sort of as I was going, with a couple of numbers. But in a second, we're going to see a couple of neater typed out examples, just so you can get a bit more of a feel for this with an actual example rather than me coming up with numbers on the fly. So, one of the variants of BEDMAS is PEMDAS, which basically means exactly the same thing. You'll notice from what we saw on the previous slide that now multiplication and division are not written in the same order. Now we've got multiplication showing up first and division showing up afterwards. And the other change is that instead of writing brackets, we've written parentheses. It doesn't really change anything. I never cared too much about the naming. Some people will say that the square ones are brackets, but the curved ones are parentheses. But really, it kind of works out the same way. Whenever you're doing math, usually if you need to put something in brackets or in parentheses, you'll use the curved ones first. That does not look like a good parenthesis, but anyway. So first you'll put them in parentheses, and then if you need to put another set around them, then you'll use the square ones just to indicate that it's different. So like if you were doing a math problem and you wanted to emphasize that something in here is being done first, and then you're doing another operation like this, and then let's say there's more outside of that, like I don't know, some division or something, divided by 5, let's say. So if you had something like this, you can use parentheses and you can use the square brackets. It doesn't make that much of a difference when you're working with these symbols at this level of math. So it's just a different term. You can call them brackets, you can call them parentheses, I don't really care. For this expression here, because we want to start with all brackets, this division by 5 over here is outside of the bracket, so for now we would ignore it. We would start by focusing on this set of brackets, and within that set of brackets there's another set of brackets. So sometimes you'll have brackets inside of brackets like this, and then you would start by solving this, then dealing with everything else that's in the big set of brackets, so that would be this multiplication by 8, and then once you have all of that reduced down to one number, which should be 40 in this case, 3 plus 2 is 5, 5 times 8 is 40, this would be 40, and then you would do the division by 5 after that, and you would have your answer. So that's the way this works. This is basically the same setup as BEDMAS, the same idea going on over here. Multiplication and division still work the same way as before. So you just do them in order from left to right, and then same deal with addition and subtraction. You're just going to do them in order from left to right, whatever you see first. The last one we'll get to in just a second. So this last one is BODMAS. That's the last sort of acronym that you can use to remember the order of operations. And it's really, really similar to BEDMAS, except that instead of writing exponents, they've changed it to an O for order. So this isn't something that I saw in school, but this is something I saw when I was working with you guys at the school last year, the year before that, that I was introduced to this BODMAS idea. And it works exactly the same way, it's just different naming. So BEDMAS, PEMDAS, and BODMAS all work exactly the same way. You start with the brackets or the parentheses, then you move on to the exponents or the order, then you do division and multiplication, whichever one comes up first, left to right. So you can do, so if you've got like something divided by something times something else divided by something else, it's not like you do both of these divisions first and then you do both the multiplications, or that you do both the multiplications and then both the divisions. You just do them in order. So if you see a division and then a multiplication and then another multiplication and then a division, do them in that order. So don't feel like for division and multiplication, it's not like you have to do one of those operations before you do all the other ones. And same deal with addition and subtraction. If you see addition or subtraction, just going left to right, just do them in that order. So it's the exact same idea as BEDMAS, PEMDAS, whatever you want to call it. These last four, the names don't really change. The order changed once for division and multiplication, but again, we know that these are interchangeable with each other and these are interchangeable with each other. So now let's take a look at a few examples. I've prepared 4 examples that we can take a look at. So I've written out a mathematical expression. I believe this is the one that showed up at the very beginning of this lesson. So what we can do is we'll just work through it. We'll examine how the order of operations works so that we can actually get a final answer. So the first step, I should have written out the acronyms somewhere on the slide, but let me just draw it in once on this slide, and then after this I'm going to stop writing it in. So our order of operations is BEDMAS, BEDMAS. So our first step, the B, is brackets. And when you're solving through the problem, if you need to write down BEDMAS and then as you go step by step, like, yep, I've taken care of the brackets and put a check mark, that's fine. If that's what helps you to remember it and make sure you're not missing any steps, do that. So our first step is brackets. So if we look at our expression over here, we do have something in brackets. So that's the first thing that we're going to want to deal with. So as we do that, we don't have any other brackets. So this is the first step, is just dealing with these brackets by themselves. So what that means is we can simply do whatever operation shows up in the brackets. And in this case, it's just 3 plus 3, so that is 6. So this gives us our slightly reformed expression here. So instead of 3 plus 3, I've put a 6 right in there. And I've added brackets here and here around the division to remind us that division happens before subtraction. So this division needs to happen before this subtraction. And I've thrown in brackets just to remind myself of that. Be careful if you do choose to add in the brackets, because if you add in the brackets around the wrong thing, for example, if you added in the brackets around the subtraction, then it would change your answer and it would be the wrong answer. So I've just added in the brackets here to highlight that the division comes before the subtraction, but you don't need the brackets to make that the case. It was already going to be that way. So our next step, if we look now, we have 3 operations left. We have multiplication here, we have subtraction here, and we have division here. So now if we look up at BEDMAS, we don't have any exponents, so this is also taken care of. Now we're on to division and multiplication. So we start with whichever one shows up first as we go from left to right, and we'll ignore the subtraction for now because we're not on that step yet. So that means we start with this multiplication here. We start with this multiplication here, we ignore the subtraction, and we take care of this division here in that order. So we'll start with the multiplication. 4 times 6 is going to be 24. And then over here with the division, we're going to have 16 divided by 4, which is 4. So there we go. Now we've taken care of the multiplication and the division. We got the 24 from the 4 times 6, and we got the 4 from 16 divided by 4. Now we have one operation left. It's just subtraction. So if we for the sake of completeness, we're done with division, we're done with multiplication, there is no addition, so the only thing left is subtraction. So we've got 24 minus 4, that's a fairly easy last step, and we get an answer of 20. So that's the way this sort of works. You see, with the brackets, we started with some stuff in the brackets, and then we got it down to just one number. Then we dealt with the multiplication and the division, got it down to one number here, and then did that subtraction and got one number for our final answer. So here's our second of 4 examples. Let's go through this one now. I'm not going to write out the BEDMAS acronym in the corner, but if you guys want to work through it, which I recommend you do, for the first example, I was really going through it and writing down a lot of things, so it's fine if you didn't for that one. But for this one, I recommend that you write it down in your notebook or on a scrap piece of paper or something, just so that you're getting a little bit of practice with this as well. It's definitely a lot easier to learn and to retain the math if you're trying to write it down yourself as well. The practice part of it is really, really important. So if you're just watching me do it, that's good, but it's not as effective as if you're doing it alongside. So for this one, I'm not going to write down as much on the screen. I'm going to explain what I'm doing, and if you guys want, pause the video now and try it yourself, and then see if my answer matches yours. See if somebody made a mistake. Maybe it was me who made a mistake. If you guys are all getting a different answer than me, let me know. Maybe I've done something wrong. But yeah, try, if you're feeling comfortable with it, pause the video, give it a try, and then watch me work through it, and we'll compare answers at the end. So the way this problem would begin, because we don't have any brackets and we don't have any exponents, we need to start with the D and M part of BEDMAS, so the division and the multiplication. So here's a multiplication, and ooh, that's a little bit off center, but you get the idea. And then here's division. So that's what we need to start with. We need to start with that product and that quotient, that multiplication and that division. So right now we're ignoring the subtraction on the left and we're ignoring the addition on the right. So if we start with this multiplication, because it shows up first, going from left to right, then we do 2 times 4, which gives us 8. So you see here, all I've changed is I've changed the 2 times 4 to be an 8. And then once again, just to highlight that the division is happening next, I've drawn in these brackets. Maybe I shouldn't have, so that it would require a little bit more work to sort of figure out what's next. But putting in the brackets is a reminder for me myself that the division has to happen next. So if we look at it now, you could add in those brackets around the division and it doesn't change the problem. But if you don't add in those brackets, it's still the same thing. Division comes before addition and subtraction, so we need to take care of this first. So we ignore the subtraction over here, we ignore the addition over there, and we just do the division in the middle. And so we do 8 divided by 8, which is going to give us 1. So then here, this 1 comes from that division, and it's really the answer to this whole thing, right? If you do all of this in one step, 2 times 4 is 8, and 8 divided by 8 is 1. So this entire section here is just 1. So now we've got 18 minus 1 plus 3. And we're on to the A and S part of BEDMAS. We're down to just addition and subtraction. But because those operations are equivalent to each other, we just do them in order from left to right. So we start over here with the subtraction, and then we'll move over there and do the addition. So it's a fairly simple process. I'm going to do it all in one step. 18 minus 1 is 17. 17 plus 3 is 20. So as you can see, maybe those of you who've been paying extra special attention have noticed that the answer to both of the first examples was 20. That was a coincidence. I'm going to try and make sure that doesn't happen this time. But basically, let's move on to a slightly more complicated example, because now we're introducing exponents. So that's just a reminder of how exponents work, since we're not on the exponents unit yet. If you have the little 2 up there, that means 2 times 2. So basically, you take this number here and you multiply it by itself this many times. Okay, so you start with the big number here, that this 2 is the reason why we've written down 2's down here. And this little 2 is why we've written exactly 2 of those numbers. So like if you counted the number of, whoa, I don't know what happened to that arrow, but if you count the number of things that we're multiplying together, it's 2 because of that little exponent 2 up there. So this thing here, this first term, 2 squared, is basically just 2 times 2, but because it's written as an exponent, we can't treat it as the same level as multiplication when we're going through BEDMAS. It needs to be done first. And so it's the same deal with this 3 squared. We're going to multiply the big number, so this big number here, 3, by itself this many times. So that's going to be 3 times 3. So it's not that you're going to rewrite an exponent as a multiplication problem. I'm writing it out as a multiplication problem so that we can calculate it in our first step. So the first step in this BEDMAS problem, since we have no brackets, is to calculate those exponents. So the first exponent, the first power there, 2 squared, is really just 2 times 2, which is 4. And the second one, the 3 squared, is really just 3 times 3, which is 9. So we end up with this. Now this time I held back on writing in the brackets around the division sign because we really don't need the brackets. Wherever I was putting in the brackets before was not changing the problem. And ideally, just to make sure that you're not accidentally changing the problem, don't add in the brackets unless you're absolutely sure of what your next step is and you're just trying to remind yourself of that next step. Basically, a good rule of thumb is you don't need the brackets. You don't need to add in the brackets anywhere, but if you find that it helps you to remember the next step, go for it. For me, I don't think it's that much of a big deal to include them, so I'm not going to include them for this problem. We're going to go through with the rest of BEDMAS. We don't have any brackets. I should hope we don't have any brackets because we already dealt with exponents, but we also don't have any exponents anymore. So now we've got one of each of the leftover operations. We've got one addition, one subtraction, one division, and one multiplication. So by BEDMAS, we have to deal with the division first, and then this multiplication after that. The division first because it comes up first, going from left to right. So if we do that, this division, 4 divided by 2, is going to be 2, and then 2 times 12 is going to be 24. So we can get rid of the division and multiplication in one step. I've actually done it in 2 steps here, my mistake. So the 4 divided by 2 gives us this 2 right here, and then 2 times 12 gives us 24. So now we're done with the division and the multiplication. All we have left is addition and subtraction. So we do that in the order that they appear from left to right. So we start on the left, 4 plus 9. We do the addition first. That's going to be 13. And then we do the subtraction after that, 13 minus 24. Since 24 is a bigger number than what we're starting with, we're going to end up with a negative answer, and it should be negative 11. So hopefully that process is making sense. Let's do one last example. So here's one last example. It includes everything that we've worked on so far. So we've got brackets, we've got exponents, we've got division, we've got multiplication, we've got addition, we've got subtraction. So let's begin with brackets. That's the first step every time in a problem like this. So we start with the brackets over there on the left. Those are the only brackets that we have, but we're starting with this. So we look at what's inside the brackets and we ignore everything else. We ignore the exponent that's outside the brackets. We ignore all of the other terms after it. It's just the thing inside the brackets right now that we're worried about. So the first thing is dealing with what's inside the brackets. In this case, it's fairly simple. It's just 2 plus 4, so that's 6. So here we can replace the 2 plus 4 with 6. Since it's just down to one number now, I don't need to write brackets around it. I've kept them there just because I had them before. But at this point, when you're down to just the one number, you can ditch the brackets because there are no more operations to do inside of those brackets. So our next step, once we've dealt with the brackets, is to move on to exponents. So we need to worry about this little 2 up here and this little 2 up here. So 6 squared, 6 times 2, or not 6 times 2, 6 to the exponent 2 means 6 times 6. So that's the same thing as 6 squared. So when we're calculating that, we can turn it into that multiplication problem in our heads or in our rough notes on the side of the page, and we get that 6 squared is equal to 36. And then the same idea for 2 squared, it's going to be 2 times 2, basically the same process as what we just did with the 6's and what we did in the last problem. 2 squared, 2 times 2, it's 4. So now we've dealt with the exponents. We've got an answer of 36 from the first one, and we've got an answer of 4 from the second one. Now we move on to division and multiplication in the order that they show up, left to right. So starting from the left, this division shows up first. So we'll do 36 divided by 4 first. 36 divided by 4 gives us 9. So that's where this 9 right here comes from. Now after that, we move on to multiplication. It shows up next, going from left to right. And since we've got no more division left to do, we can just look at this and say, well, multiplication comes before subtraction. So let's do that first. So we do the multiplication. 9 times 9 is going to be 81. So that's where this 81 comes from. And then all that we have left is our last operation, which is subtracting 3 from that, which gives us a final answer of 78. So that's 4 examples about how BEDMAS works. There's 3 different ways to remember it, 3 different acronyms that you can use to remember BEDMAS. Hopefully this lesson has made sense. If it hasn't, you guys can reach out to me by email or leave a comment or send me a message on the Instagram account for the channel. But yeah, hopefully this makes sense. If you're stuck, let me know. I can get you some extra resources or make some extra practice problems for you to help explain it. And before you do that, or even after you do that, one of the resources I would direct you to is any lessons I made on this stuff last year, because I'm reviewing these things since I've covered them in previous videos on the channel. So if you find that you're getting stuck with a concept, just go to the channel page and scroll down through last year's lessons. They're numbered from 1 to 56 or so, and see if you can find the same concept there. For this first unit, there is a lot of overlap. A lot of the things that we're going to be doing in this class and the next few classes are things that I covered last year. So if something's not making sense, go back to that. Once we get into new units, of course, that won't really be an option, but I'm going to slow down with explanations for those. So hope this made sense. If you don't have any questions, I will see you all in the next video. Have a good one.